Chapter 5 Squares and Square Roots. First question. What will be the unit digit of the squares of the following numbers? Unit digit of the squares. So here the unit digit is 1. 1 square, again it is coming 1 only there in the unit place. Here unit place digit is 2. It's a square. 2 square, that means 4. So in the square of this number, unit digit is 4. Then here 9. 9 square is 81. So 1 is the unit place digit. Here 3. 3 square is 9. So 9 is the unit place digit. 4. 4 square is 16 and 6 is coming in the unit place. 7 square, that is 49. So 9 is the unit place digit. 8 square 64. So 4 is there in the unit place. 0 square 0. 6 square 36. So 6 will be in the unit place. 5 square is 25 and 5 is there in the unit place. Second question. The following numbers are obviously not perfect squares. Give reason. We know that a number ends with 2, 3, 7 or 8 at unit place is not a perfect square. So unit place digit, when we are looking here, is coming 7. If the unit place digit with the 7, that means it's not a perfect square. Here 3. Here 8. 2. So these numbers are not a perfect square. Here the reason 3 zeros are there. Even number of zeros to come. Not even number. Even number of zeros. To become a perfect square, the even number of zeros supposed to be there at the end. Here again 2 is coming the unit place. This one with 3 zeros. So not an even number of zeros. Even number of zeros. Here also just 1 0. Not an even number of 0 is the reason. So for each and every number we can write the reason. A number ends with 2, 3, 7 or 8 at a unit place is not a perfect square. Same way the number ends with even number of zeros, then only that will become perfect square. If not an even number of zeros, then that also not a perfect square. Third question, the squares of which of the following would be odd numbers? 431 square, that will be odd number. 2826 square, that means that is an even number. Here 9 square 81, that means this is an odd number, so square that also will be odd number. For this square, that will be even number. Fourth question, observe the following patterns and find the missing digits. 11 square 121, 100 square, that means 1 and then 1 0, then 2 0 1. Here 1001 square, 2 zeros here, so in between 2 zeros is coming. Here 4 zeros are there, so we have to put in between 1 and 2 4 zeros. Here also 4 zeros. Here 6 zeros are there, so after 1 6 zeros. Then put 2, again 6 zeros, then 1. This is the pattern. Fifth question, observe the following pattern and supply the missing numbers. 11 square, that is coming 1 2 1. Here 1 0 1. So 1 0 2 0 1 1 0 2 0 3 0 2 0 1. Here it will come 10, 20, 30, then 40. After that 30, 21. Here already this number is given. Here it will come 10, 10, 10. Here 3 times, here one more time, and then 1 square. Question number 6. Using the given pattern, find the missing numbers. Here 1 into 2, 2. Next number 3. 2 into 3, 6. Next number is 7. 3 into 4, 12. Next number is 30. So 4 into 5, here it will come 20. Next number 21. 5 into 6. 5 into 6, 30. Next number 31. 6 into 7, 42. Next number 43. Without adding, find the sum. We know that sum of n odd numbers is equal to n square. Here 2, 4, 5. N is 5. So n square, that means 5 square, which means 25 is the answer. Here n is equal to 5. Here n is coming 10. So it will come as 10 square, which is equal to 100. N is equal to 10. Here n is equal to 12. So that will come as 12 square, which means 144. Here n is equal to 12. So the rule is sum of n odd numbers. How many numbers are there? And if n numbers, the sum will be n square. Here 10 numbers, 10 square is equal to 100. Here 12 numbers, 12 square is equal to 144. That is the sum of odd numbers. Express 49 as the sum of 7 odd numbers. So same way we can write it here. 7 odd numbers. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. 7, 3, 6, 7. That means n is equal to 7. 7 odd numbers, which is equal to 49. You can write that is equal to 49. Here 121 as sum of 11 odd numbers. So we can write 121 is equal to 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19 plus 21. 11 numbers. 3, 6, 9, 10, 11. So n is equal to 11. Sum of 11 odd numbers. If we are adding all this, we will get 121 as the sum. How many numbers lie between the squares of the following numbers? We know that numbers between the squares of two numbers, n square and n plus 1 square, that is equal to 2n. Here between the squares of these numbers, that means between 12 square and 13 square. First number is n, next one is n plus 1. So n square and n plus 1 square, which is equal to 2 times n. 2 times of the first number, which is equal to 2 into 12. Is equal to 24 numbers. Here between squares, 25 square and 26 square is equal to 2n. 2n means 2 into 25 is equal to 50. between 99 square and 100 square, that is 2n, 2 times of first number, is equal to 198. So 198 numbers will be there in between 99 square and 100 square. Exercise 5.2, first question, find the square of the following numbers. First number 32. We know that 32 we can write as 30 plus 2. Then square of this number, that means 32 square, which is equal to 30 plus 2 the whole square. This we can write as 30 plus 2 2 times. 30 plus 2 into 30 plus 2. Which means first number, this 30 into second bracket. 30 into 30 plus 2 plus 2 into second bracket, which is equal to 30 into 30, 900, 30 into 2, 60, 2 into 30, 60, 2 into 2, 4, which is equal to, when we are adding, 1024. So we can write that is 32 square is equal to 1024. Same way next number 35. 35 square we can write as 30 plus 5. So square of that, and that is equal to first number 30 into that bracket, 30 plus 5, again second number 5 into 30 plus 5, that bracket, which is equal to 30 into 30, 900, plus 30 into 5, 150, 5 into 30, 150, 5 into 5, 25, which is equal to 1225. That means 35 square is equal to 1225. Next number 86. 86 square. That means we can write that as 80 plus 6, the whole square, which is equal to, this we can write as 80 plus 6 into 80 plus 6. And first term into second bracket, 80 into that bracket, 80 plus 6, plus second term into this bracket, 6 into 80 plus 6. And we are multiplying, 8 8s are 64 and 2 zeros, plus 8 6 are 48 and 0. Here also 8 6 are 48, so 480 plus 36, which is equal to 7396. Next number 93. 93 the whole square is equal to 90 plus 3 the whole square, which means 90 plus 3 2 times. The whole square means 90 plus 3 2 times, which is equal to first term into second bracket. We are multiplying like this way. So 90 into 90 plus 3, then with 3 also, plus 3 into 90 plus 3, which is equal to 90 into 9, 9 into 9, 81 and 2 zeros, plus 90 into 3, 270, plus 3 into 90, 270, plus 3 into 3, 9, which is equal to 8100 plus 270 plus 270 plus 9 is equal to 8649. Next number 71. 71 square we can write as 70 plus 1 the whole square, and that is equal to 70 plus 1 into 70 plus 1, which is equal to 70 into second bracket plus 1 into second bracket, which is equal to 49 plus 70 plus 70 plus 1, and that is equal to 5041. 5041. Next one is 46 square, that means 40 plus 6 the whole square. 40 plus 6 into 40 plus 6. When we are opening the bracket, it will come 2116. That means 46 square is equal to 2116. Write a Pythagorean triplet whose one number is 6. So we can write that as let m square minus 1 is equal to 6. M square minus 1 is equal to 6, which implies m square is equal to 6 plus 1, 7. We know that it is not an integer. The value of m will not be an integer here. So we will try for the next one. M square is equal to 7, which means m is equal to root 7. That means the value of m will not be an integer. So we can try the next one. Let 2m is equal to 6, which implies m is equal to 3, and it's an integer, which is an integer. So we can take m is equal to 3. That is m is equal to 3. Then m square minus 1. M square minus 1 is equal to 3 square minus 1. That means 9 minus 1 is equal to 8. Then m square plus 1. 3 square plus 1. 9 plus 1 is equal to 10. And 2m is equal to 6. Therefore, we can write, therefore, the required triplets are 6, 8, 10. That's number 14. So first we can try that. Let m square minus 1 is equal to 14, which implies m square is equal to 14 plus 1, 15. Which implies it will come that as root 15, which is not an integer. That means the value of m will not be an integer. Then we can try that next one. Let 2m is equal to 14, which implies m is equal to 14 by 2, 7, which is an integer. From that we can find m square minus 1 is equal to 7 square minus 1. 49 minus 1 is equal to 48. And m square plus 1, which is equal to 7 square plus 1. 49 plus 1 is equal to 50. Then we can write, therefore, the Pythagorean triplets are. So we can write the required triplet are 14, 48 and 50. Next number is 16. So first we can take let 2m is equal to 16. We know that the Pythagorean triplet using general form, that means 2m, m square minus 1 and m square plus 1. So first we will try 2m is equal to 16, which implies m is equal to 8, which is an integer. So we can take that is 2m as 16, then m square minus 1. M is equal to 8. M square minus 1 means 8 square minus 1. 64 minus 1, that is equal to 63. M square plus 1, which is equal to 8 square plus 1. 64 plus 1 is equal to 65. Therefore, the Pythagorean triplets are 2m, that means 16, then 63 and 65 are the Pythagorean triplet. Next one, 18. So we can take let 2m is equal to 18, which implies m is equal to 18 by 2, 9. It's an integer, which is an integer. From that, m square minus 1 is equal to, m is 9. So 9 square minus 1, that means 81 minus 1 is equal to 80, and m square plus 1 is equal to 9 square plus 1, 81 plus 1 is equal to 82. So we can write therefore the required triplet are 2m is 18, then m square minus 1 80 and 82. 18 here, m square minus 1, m square plus 1. So Pythagorean triplet using the general format 2m, m square minus 1, m square plus 1. Exercise 5.3, first question. What could be the possible ones digit of the square root of each of the following numbers? 9801. Here 1 is coming. The square root of this number, ones place digit. Then we know that is 1 square is equal to 1, and 9 square also can be as 1. So in one's place of the square root of this number may be 1 or 9. 1 or 9. 1 square and 9 square both ending with 1. Here 6 is coming. That means 6 square or 4 square. 4 square is 16. There also 6 in one's place. 6 square 36. There also 6 can be there in one's place. So the ones digit in the square root of this number may be ending with 4 or 6. Here 1 is coming. 1 is coming, that means same as the first one, 1 square or 9 square. So that square root of this number may be end with 1 or 9. Here 5 is coming. So 5 square only, it will end with 5. So that means the ones digit in the square root of this number can be 5. Second question, without doing any calculation, find the number which are surely not perfect squares. We know that not perfect squares, that means the numbers ending with 2, 3, 7 or 8 is not perfect square. Any number ending with 2, 3, 7 or 8. Here ending with 3. So not perfect square. 7, 8. So these are not perfect squares. 441, that is a perfect square number. So we can write here ending with this number 153 ending with 3. Therefore that not a perfect square number. 257 ending with 7. So not a perfect square number. 408 ending with 8. So not a perfect square number. Here 441, that is a perfect square number. Rule is numbers in ending with 2, 3, 7 or 8 is not a perfect square number. Third question, find the square root of 169 by the method of repeated subtraction. So we had to subtract odd numbers 1, 3, 5, 7 etc. till getting 0. How many times we repeatedly subtracted, that will be the square root of the number. Here 100 minus 1, 99. Then we had to minus from that 99, 3, 96 minus 5, 91. So all the odd numbers in order 1, 3, 7, 5, 7, 9 etc. till getting 0. Here we can see 10 times repeatedly subtracted. 10 times. Repetition is gone. So we can write root of 100 is equal to 10. Here same way 169 started with 1, 3, 5 etc. Finally 13 times subtraction here. 1, 2, 3 like 13 subtraction. So square root of 169 is equal to 13. Fourth question, find the square root of the following by prime factorization method. First number 729. 729 we can divide by 3. Again by 3. So here we can see 3 6 times. We can write 3 into 3 6 times. So square root of 729 is equal to, we have to take 1 3 from a pair. So 3 into 3 into 3 which is equal to 27. Square root of 729 is equal to 27. Next number 400, that we can, when we are dividing by 2 and 5, we'll get here 4 times 2 and 2 times 5. So root of 400 is equal to, from this pair we have to take 1, 2 into 2 into 5. So 4 into 5, 20 is the square root. By prime factorization method, next numbers, square root of 1764. Here we are getting 1 pair 2, 1 pair of 3, 1 pair of 7. So from that we are taking 2 into 3 into 7, 42. 4096. Here we are getting 6 pairs of 2. 12 2s are here. And we are making pair, that means 6 pairs. So 6 times 2, that is 64. Next 7744. Here 2 and 11. So 2 into 2 into 2 into 11, 88. In 9604, 2 1 pair, 7 2 pairs. 2 into 7 into 7, 98. Next 7th one, the number 5929. We are getting 7 1 11 1 pair. So 7 into 11, 77. 8th one, 9216. That we are getting 2 5 pairs and 3 1 pair. So square root is 96. 529 23 square. 23 into 23. So root of 529 is 23. 8100 we are getting 2 into 3 into 3 into 5 as the square root, which is equal to 90. Fifth question, for each of the following numbers, find the smallest whole number by which it should be multiplied so as to get a perfect square number. Also find the square root of the square number so obtained. Here 252. So first we have to prime factorize that 252. When we are prime factorizing, dividing by 2, here we can see which is equal to 2 into 2, 3 into 3 into 7. Here 2 is in a pair, 3 also a pair, and 7 is single or one time only. So the number to be multiplied, so we can write one more 7 we need to make the number as a perfect square. So 7 is the smallest whole number by which it should be multiplied to get a perfect square number. So here we can write 7 has no pair. Therefore 7 is the smallest number to be multiplied to get a perfect square number. That means we have 252 here, the number, that into 7. When we are multiplying with 7, we will get 1764. 1764. Then the square root of 1764 is equal to, already we have this number. So from that one pair we can take 2 into 3. Now one more 7 we multiplied. So 7 also it became a pair. So into 7, which is equal to 42. Here 180, when we are doing the prime factorization, we can see one pair of 2, one pair of 3 and just one 5. Here 5 has no pair, which means 5 is the number, the smallest whole number by which the given number is multiplied to get a square number. For that, 180 into 5 we had to multiply. Here with 5 we will get 900. Then the square root of 900 is equal to 2, 3 and one more 5 when we multiplied here. So from that also 5. 2 into 3 into 5 is equal to 30. Square root of 900 is equal to 30. The next number 1008. When we are doing the prime factorization, 7 has no pair, only one time. So 7 is the smallest whole number by which the given number should be multiplied to get a perfect square. Therefore, we are multiplying 1008 with 7 and 7056. Then root of 7056 is equal to, already we can take from here 2 into 2 into 3. Now 7 also become pair, so into 7, which is equal to 84. Here 2028, when we are doing the prime factorization, one pair of 2, one pair of 13 and 3 only one time. 3 has no pair. So 3 is the smallest whole number to multiply. When we are multiplying 6084 and root of 6084, that is 2 into 3 into 13 is equal to 78. Next number 1458. Here 2 is the only one time, that means 2 has no pair. So 2 is the number to multiply to make a perfect square number. 1458 into 2, 2916 and square root of that is equal to 54. Just one 768 when we are doing the prime factorization. 4 pairs of 2 and 3. So here 3 has no pair. Therefore, 3 is the smallest whole number to multiply 768 to make a perfect square. So 768 into 3 is equal to 2304. Root of 2304 is equal to, from here one pair we can take 2 into 2 into 2 into 2 into 3 is equal to 48. Question number 6. For each of the following numbers, find the smallest whole number by which it should be divided so as to get a perfect square. Also find the square root of the square number so obtained. First one 252. So first we had to prime factorize that number 252. We can divide by 2. 126 again by 2. 6 3 then by 3. 2 1 3 7 7 1. So here we are getting that as 2 into 2 into 3 into 3 into 7. Here 7 has no pair. Here the question which find the smallest whole number by which it should be divided. So 7 is the without pair, which means we have to remove that. So 7 is the smallest number to be divided. That is 7 is the smallest whole number by which 252, which 252 should be divided to get a perfect square. So 252 divided by 7, which is equal to, when we are dividing by 7, we will get 36, which implies root of 36 is equal to 1 2 from here, 1 3 from here. That means 2 into 3 is equal to 6. Next number 2925. Same way we have to prime factorize and find the smallest number which one to divide to make that a perfect square. Here 2925, when we are doing the prime factorization, one pair of 3, one pair of 5 and 13 is one time only. That means 13 has no pair. Therefore 13 is the smallest number to divide 2925 to make to get a perfect square. So 2925 divided by 13 is equal to 225. Root of 225 is equal to 1 3 from the first group, 1 5 from there. So 3 into 5 is equal to 15. When we are dividing, this 13 is removed. Here 396. After prime factorization, one pair of 2, one pair of 3 and 11 is there. Then here 11 has no pair, which means 11 is the number to divide 396 to get a perfect square. So when we are dividing with 11, we will get 36. Root of 36 is 2 into 3, 6. Next number 2645. There 5 into 1 pair of 23. 5 has no pair. So 5 is the smallest number to be divided. And then 2645 divided by 5 is equal to 529. Root of that is equal to 23. The next number 2800. After prime factorization, 2 pair of 2, 1 pair of 5 and 1 7. Which means we have to divide. 7 has no pair. So 7 is the smallest number to be divided. This 2800. 2800 divided by 7 is equal to 400 and square root of that is equal to 1 time from each pair. 2 into 2 into 5 is equal to 20. Next number 1620. After prime factorization, 1 pair of 2, 2 pairs of 3 and 1 5. 5 has no pair. So 5 is the smallest whole number to be divided. After division, we are getting 324. So root of 324 is equal to 2 into 3 into 3 is equal to 18. Question number 7. The students of class 7 of a school class 8 of a school donated 2,401 rupees in all for Prime Minister's National Relief Fund. Each student donated as many rupees as the number of students in the class. Find the number of students in the class. So the amount donated, that is rupees 2,401. Total number of students in the class, which means root of 2,401. For that, first we have to prime factorize the number. Then we will get there root of here 7 square into 7 square, which means we can take only 1 from each group. So it will come 7 into 7, which is equal to 49. So the number of students in the class is equal to 49. 8th question. 2025 plants are to be planted in a garden in such a way that each row contains as many plants as the number of rows. That means number of rows and number of plants in each row, that is same. Find the number of rows and number of plants in each row. That means total number of rows is equal to total number of plants in each row. Here total 2025 plants, which means we have to find the total number of rows or total number of plants in each row. We have to find the square root of the given number 2025. Which means 2025, we know that when we are doing 3 2 pairs and 5 1 pair. So when we are taking that square root of that, from here also we have to take the square root, which means 1 3 from there, and from the next group 1 3 and 5 from there, which is equal to 3 into 3 into 5 is equal to 45. That means the number of rows and number of plants in each row is equal to 45. Question number 9. Find the smallest square number that is divisible by each of the numbers 4, 9, 10. Divisible by 4, 9, 10. So LCM of 4, 9, 10, that is 180. That means the least number divisible by 4, 9 and 10 is 180. Then after doing prime factorization of 180, we are getting here 2, 1 pair, 3 also 1 pair, but 5 has no pair, only one time. So the required smallest number, find the smallest square number that is divisible. Here we need one more 5. So 180, the given number, that into 5, which is equal to 900. So 900 is the smallest square number which is divisible by 4, 9 and 10. In the question, find the smallest square number that is divisible by 8, 15, 20. Same as that. So first we have to find the LCM of these three numbers. The smallest number divisible by 8, 15, 20, which means LCM of these three numbers. So when we are finding the LCM of these three numbers, we are getting 3 times 2, 1 times 3, 1 times 5 is equal to 120. Here we can see 2, 3, 5 of no pair. So we have to multiply by 2, 3, 5 to make the given number as a to make a perfect square. So the required smallest square number which is equal to that 120 into, here we need one more 2, 3 and 5. 2 into 3 into 5. Which means 120 into 30, which is equal to 36, 3600. So the required smallest square number is 3600. Next, exercise 5.4. First question, find the square root of each of the following numbers by division method. Here 2304. So first we have to write the number here 2304 and group 2 as a or pair of digit in a group from right to left. And take the first group 23, and below 23 find out the perfect square number. Perfect square is 16. That means 4 into 4 is equal to 16. Then we are minusing that, here it will come 7. Then put the next group down 0, 4. Now the same time double this number and write it here. That will come 8. Now one more digit we need here, that we have to check and find out. Here 704. To get 704, here another number. For example 8. If you are taking 8, then multiply with that 8 itself. 8 8s are 64. Then 6 8 8 are 64 plus 6 70. So 704 again. Which digit you are taking? Multiply with the same digit. So it will come here 8 and also on top 8. 704. 0. So we can write here root of 2304 is equal to this number 48. Same way we can do the next. Next number is 4489. So first we have to write the number 4489, then group And we are grouping. The first group is coming 44. In 44, find the perfect square just below that number. That is again 36. Which means 6 into 6. 6 into 6, 36. 44 minus 36, 8. Then the next group down. So that will come 89. So 889. The same time double this number. 6 into 2 or 6 plus 6. 12, and here one digit we have to find such that the number, that digit into this number is equal to 889. Here we know that we are getting 7. So 127 into 7. It will come 889. And when we are minusing, it will come 0. So we are getting square root of that number is equal to 67. Your next number 3481. Here we have to group, and then 34. Below 34, that is coming 25 is the perfect square. 25. That means 5 square. 5 into 5, 25. Then 34 minus 25, 9. Then next group, that is 81. 981. Double this number, that is 10. And here one digit we have to find such that that digit into this number is equal to 981 we have to get. So 9. When we are multiplying 109 by 9, we will get 981. That means the square root of this number is equal to 59. Next is 529. For that 529, 3 digit only. So from right we have to make the group. Here only one digit there in the group. So below 5, 4 is the perfect square. So 2. 2 into 2, 4. And here 1 is the remainder. Next group 29. At the same time 2 into 2. Or 2 plus 2, that is 4. 4 into 1 digit supposed to come here. So we know that 9 is ending. That means it 3 square of 3 or square of 7. So if we are taking 3 here, 43 into 3, that will come 129. Then here the square root of 529 is equal to 23. Next number 3249. 3249 we can group like the same. And we are grouping 32. Below 32, the square perfect square is 25. That means 5. 5 into 5, 25. And we are minusing that, we will get 7. Next number is 4. The next group is 49. So 5 plus 5, that means 10. 10 into 1 digit we have to find, that is 7. Here also 7. So 107 into 7 will come 749. So square root of that number is equal to 57. Here 1369. Grouping as 13 and 69. Below 13, 9 is the perfect square. So 3 into 3, 9. Remainder 4. Next group 69. 469. Double this 3. That means 6. Or 3 plus 3. 6. Then find the digit such that the unit place is 9. So 7. 7 square. 49 so unit place 9. So 67 here and here 37. So the square root is 37. Next number 76, and then 7921 square root, that is 89. 576 square root is 24. 1024 square root is 32. 3136, that is 56. 930. Second question, find the number of digits in the square root of each of the following numbers without any calculation. Number of digits in the square root. Here 2 digit, that means 1. We know that the number of digits in the square root is equal to number of digits in the number by 2. If n is even, then n by 2. Here n is equal to 2, even number. That by 2, which is equal to 1. If n is odd, then n plus 1 by 2. Number of digits in the square root is equal to n by 2 if n is even, n plus 1 by 2 if n is odd. Here 2 digits are there, n is even. So n by 2, that means n by 2, that means 2 by 2 is equal to 1 digit will be there in the square root. Here n is equal to 3, odd number, which implies n plus 1 by 2. That means 3 plus 1 by 2, 4 by 2 is equal to 2 digits will be there in the square root of 144. Here number of digits n is equal to 4, which means even number, n is even number. So n by 2, which implies 4 by 2 is equal to 2 digits will be there in the square root of 4489. Here 2, 4, 5. N is odd, n is equal to 5, odd number, which means n plus 1 by 2. That means 5 plus 1 by 2, 6 by 2 is 3 digits will be there. Here 6, n is equal to 6, that means n is an even number, so n by 2, which is equal to 6 by 2 is equal to 3 digits will be there in the square root of that number. Third question, find the square root of the following decimal numbers. First one 2.56. 2.56 here. First we have to group that, and 2 below 2 the perfect square is 1. That means 1 square. 2 minus 1, 1. And then next group, that is 56. Put the decimal point here. Now 156, and then double of that 1, that is 2. Here the digit which is 6, if you are putting 6 here, 26 into 6, that will come 156, and minusing 0. So the answer is root of 2.56 is equal to 1.6. Next number, that is 7.29, square root of that by division method. 7, first we try the number 7.29, group that, and then here 7, below 7 the perfect square, that is 4. So we can write that as 2 into 2, 4, minusing here 3, next group 29, so 329, put the decimal point here. Then in 329, here 2, double of 2, that is 4, and here the digit we had to find. So here we can see 7 is the digit there. So 47 into 7, 329, and when we are minusing 0, so the square root is 2.7. Next number 51.84. Here below 51, that is 49 is the perfect square. That means 7 square. 7 into 7, 49. When we are minusing here 2, then next group, that is 84. Put the decimal point here, corresponding way, and 281, double the 7, 7 it will come, 7 plus 7, 14, and the digit which one to end with 4. So we know that 2 is coming there, 2 squares, that is 4, so 7.2, 284, that minus, the answer is 7.2. Next number 42.25, 42.25. So we can write 42.25, group that, below 42 the perfect square is 36. So we can take 6, 36, minusing will come 6, the remainder, next group is 25. Put the decimal point corresponding to that. There in 625, double this number, or 6 plus 6, 12, and here the digit 5 ending with 5, that means 5 is supposed to come over here. 125 into 5 is equal to 625. So here 5. The answer is 6.5. Next number is 31.36. Below 31, the perfect square is 25. So 5 square. And 6 is the remainder. Next group is 36. Put the decimal point. Then 600, double the number, 10. And here one digit we have to find such that 636 to get. So 6 is the number. 106 into 6 is equal to 636. So that 6 will come over here also. So square root of that number is 5.6. Question number 4. Find the least number which must be subtracted from each of the following numbers so as to get a perfect square. Also find the square root of the perfect square so obtained. The first number is 402. So 402 we can group and find the square root. Here 4. So first we can take 4 is a perfect square. So 2. 2 into 2, 4. 0, and next group that is 0, 2. Here we can see in 0, 2 this we will not get any number such that double of 2, that is, so 4 into 4 dash, that way no number will come. So we can put here 0. And here we can see 2 is the remainder. Can write here 2 is remainder. Two is the remainder. So we can write 2 is the least required number to be subtracted from 402 to make a perfect square. When we are subtracting 2 from 402, it will come 400, and that is a perfect square. That is, 2 is the least number to be subtracted from 402 to get a perfect square. So the new number is 402 minus 2 is equal to 400, and the square root of that new number 400, which is equal to 20. Find the square root of the perfect square. So here 400, that is 20 here. Next number, that is 1989. After dividing that to find the square root, here we are getting 44 and 53 is the remainder. Remainder is 53. That means that we have to remove from the given number. We have to subtract from the given number. So we can write 53 is the least number to be subtracted from the given number. So the new number is equal to 1989 minus 53. That means 1936. Then the square root of that number, which is equal to 44. Here 3250, when we are doing 1 is the remainder. So 1 is the least number to be subtracted from 3250 to get a perfect square. The new number is equal to 3250 minus 1 is equal to 3249, and square root of that is equal to 57. Next number 825. So first we have to find the square root. Below 8 the perfect square is 4. That means 2 square. Then minusing 4, next group is 25. So 425. Then we are taking the double of that. So it will come 4 and 1 digit is missing. That is 8. Here also 8. So 48 into 8, it will come 384. Minusing that, we will get 41. So here the remainder is 41. Then we can write 41 is the smallest number to be subtracted from 825 to get a perfect square. And find the new number, and square root of that will be 28. Here the new number is 825 minus 41 is equal to 784, and root of that is 28. Next number 4000, when we are dividing that, 63 is the square root of that, and 31 is the remainder. So 31 is the least number to be subtracted from 4000 to get a perfect square. So 4000 minus 31 is equal to 3969. That is the new number. Square root of that is equal to 63. Fifth question, find the least number which must be added to each of the following numbers so as to get a perfect square. Also find the square root of the perfect square so obtained. First number 525. When we are dividing that 525, here 4 and 1 digit we need. So 42 into 2 we are getting here 84. And remainder, if we are writing here 84, the remainder it will come, that means 125 minus 84, that will come 41. If we are taking here 3, then 43 into 3, that will come 129. So take the next number, not the below number, take the next number. 43 and by 3. 43 into 3, here it's coming 129. Here we can see, find the difference between these two. To make that is 129, that is a perfect square. For when we are doing here, we need 4 more. 129 minus 125, that is 4. So that number we had to add with 4 is the smallest number to be added with 525 to make a perfect square. Here therefore we can write 4 is the least number to be added and 525 plus 4 is equal to 529 is the new number and square root of 529 is equal to 23. Now the next number 1750. First, same as that before, what we did, 1750 we had to group and then divide. Below 17, 16 is the perfect square. So 4 square is 16. When we are minusing, it will come 1. Next group, that is 50. So it is coming as 150. Double this digit, that will come 8, and here 1 digit we had to find. If we are taking there 1 in that place, 81 into 1, it will come, that is 81. If you are taking 82 in here as 2, 82 into 2, that will come 164. Now we can see here 150, next number, that is 164. If you are taking 2, so it will come 164. Then the difference between these two, 164 minus 150, that is equal to 14. So 14 is the difference of these two numbers. So 14 is the least number to be added to make that as a perfect square. Here we can write 14 is the difference of these two. 14 is the least number to be added. Therefore, the new number is 1750 plus 14. That is equal to 1764 and square root of that is 42. Here next number is 252. When we are doing here 2 one time and then 152. In 152 we have to check here after 2. The digit which is supposed to come over here. If you are taking 5, 25 into 5, it will come 125. 125 is less than 152. So next number 6 we have to put here. Then 26 into 6, 156. 156 is just before that. That means greater than 152. So we have to take the number such that the product supposed to come greater than the number. Then only we can add the least number to be added. So that 6 we can put over here. And here it is coming 156. Then take the difference of these two. 156 minus 152, which is equal to 4. Now 4 is the least number to be added with 252 to make a perfect square. So we can write the new number is 252 plus 4 is equal to 256 and root of that is 16. Now next number 1825. In that number, when we are dividing here, after 16 is a perfect square, so 4 squares minusing 2, 225, here doubling that 8, then it will come. Here we had to find the number such that just before or just bigger than this number. So if you are taking 2, 82 with a 2, it will come 164, that is below 225. If you are taking 3, 83 into 3, that will come 249, that is more than or greater than 225. So we have to take that number, 43. And now here 83 into 3, 249. Then find the difference between that. 249 minus 225. 225 is equal to 24. So we can write 24 is the least number to be added with 1825 to get a perfect square. So here we can write 249 minus 225, that is 24. So 24 is the least number to be added with 1825 to get a perfect square. Therefore the new number is equal to 1825 plus 24, that is 1849. Then square root of that is 43. We are taking like this way, the bigger number than the remainder here, and that will come, we can straight away we can write the square root 43 here. Here after doing till here 12 is coming over here. If you are putting 0, that will come, that means 16. If you are multiplying with a 0, the answer it will be 0 here. And if you are taking 161 multiplying, it will come 161. So we have to take the next one, 0, that means less than 12, take the bigger one with 1. So 161. And the difference between that means 161 minus 12 is equal to 149. So 149 is the least number to be added with 6412 to get a perfect square. So here 161 minus 12, difference of these two numbers, that is 149. That means 149 is the least number to be added with 6412 to get a perfect square. So the new number is equal to the given number 6412 plus 149. It's equal to 6561, and square root of that is equal to 81. Next question, 6th one. Find the length of the side of a square whose area is 441. So square, length of the side we had to find, area is given. So we can write it here, area of the square. Area of the square, which means side square. Area of the square is equal to, that formula is side square. That is given as 441. Now here we have to find length of the side. Therefore, length of the side means square root of 441. So we can find 441 square root by division method. Here 2 times 4 and 41. And we are taking that double, here 4 and 1, 41 into 1. So it's equal to 21. So we can write the length of the side of the square is equal to 21 meter. This 1 meter square area. So in the question, in a right triangle ABC, angle B is equal to 90 degree. And AB is 6 centimeter, BC is 8 centimeter, find AC. We know that AC square is equal to AB square plus BC square by Pythagoras theorem. So here AB is given as 6 square plus BC is 8 square. So which is equal to 36 plus 64 and that is equal to 100. Therefore, AC is equal to AC square is 100, then AC is equal to root of 100 is equal to 10 centimeter. Here AC is given as 13 centimeter, BC 5 centimeter, find AB. By Pythagoras theorem, AC square is equal to AB square plus BC square. That means 13 square is equal to AB we have to find that plus 5 square, which implies AB square is equal to 13 square minus 5 square, which is equal to 169 minus 25, that is equal to 144. Therefore, AB is equal to root of 144, that is equal to 12 centimeter. So, AB is equal to 12 centimeter. Question number 8. A gardener has 1000 plants. He wants to plant these in such a way that the number of rows and number of columns remain same. Find the minimum number of plants he needs more for this. So, number of rows is equal to number of columns. Total number of plants, that means number of rows into number of columns, which is equal to 1000 here, 1000 plants. So these are supposed to be equal. For that we have to find the square root of that. So 1000 must be a perfect square number. Then only we will get equal number of rows and columns. So to find the perfect square number, first we have to check 1000. That is not a perfect square number. So we have to find the minimum number of plants he needs more for that. So here if you are taking 6 and we have to find one digit here. If you are taking 1, it will come 61, that is the smaller number. At the same time if you are putting 2 here, 62 into 2, it will come 2 into 2, 4, 12, 124. And the difference between these two, that is 24. So we can directly write here 124 minus 100, that is 24. So he needs 24 plants more to make it same number of columns and rows. So we can write the minimum number of plants required by him is equal to 24. Here question number 9. There are 500 children in a school. For a PT drill, they have to stand in such a manner that the number of rows is equal to number of columns. So we can write number of children in a row is equal to number of children in a column. We can mark that as, let that be X. So total number of children, that means number of children in a row into number of children in a column. So if we are taking it for our convenience, so that as X, number of children in the row and in the column as X. So that will come X into X, which is equal to X square. And that is here given as 500. And here, how many children would be left out in this arrangement? When we are dividing 500 or finding the square root of 500, here 2 times 4 and 4. Here when we are taking, that is 2. So 2 into 2, here 84. And when we are minusing that, it's 16. So X square, that is here given as 500. That means root of X is equal to root of 500. And here we are getting 16 children are left out. If we are taking 22 children in a row and 22 children in a column. So we can write here the question, how many children would be left out in this arrangement? 16 children were left out. Here when we are total number of children in a row is equal to number of children in a column, that is X, both as X. So total number of children is equal to X square, that is given as here 500. To find the number of children in a row, that means X, root of 500. When we are finding the root of 500, we can see 16 children are left, or 16 is the remainder. So the new number to make a perfect square, 500 minus 16, that is 484. Square root of 484, that is 22. Now here how many children are left out? So 16 students will be left out in this arrangement, and 22 children in a row and 22 children in a column. Number of children in the row and column is equal to 22.